So here's our rectangular coordinate system. There's a couple ways of thinking about this. One way is we first walk out to the X location. And then from there, we walk down or up. And since this is a negative y, we're going to walk down to the y location. And so that's how we can graph this point. Now, another way we can think of graphing it, so again, this is our x coordinate, and that's our y coordinate. We can also think of it as the intersection. I didn't go about this method, but it's a method that I don't think is bad. This is the vertical line, x equals 2. This is the horizontal line, y equals -3. And where they intersect, that's where our point is located. So that's another way of graphing that we can do. And I'll show you another way of using this method. In some ways, I think this method's a little clearer, but they use this in the text. So any questions about these two? All right. So let's graph this. So let's say we're going to graph 0, 4. Now, if we take a look, again, this is our x, and that's our y. So let's go with the line x equals 0. Now, x's are going to be vertical lines. So it's a vertical line passing through x equals 0. And then y is a horizontal line. So y equals 4. And where these intersect, that's the point 0, 4. Questions about that? So if you just remember, x will be vertical line, y is horizontal line. Where those intersect, that's the location of that point. I think they use fill in, but I'm going to use complete. So what we have are x and y coordinates. So there's an x, there's a blank y, here's a blank x, and there's a y. So let's try this one first. So this one, we actually have a number for x, and we want to find y. That's the one we're missing. So this will be 3 times 4 minus 2y is equal to 6. Or 12 minus 2y equals 6. Now we're going to solve for y, because y is what we're missing. So subtract 12 from both sides. We'll continue on over here. We'll get negative 2y equals negative 6. Divide by negative 2. Get y is equal to 3. So that means we put a 3, excuse me, over here. Use the green marker. Now let's go to this point. So we start out with our equation. We don't know x, but we do know y. It's negative 6. And we subtract 12 from both sides. Continue on over here. We'll get 3x equals negative 6 again. Divide both sides by 3. Let's double check. We'll get x is negative 2. And let me double check. Let me make sure I didn't make an arithmetic mistake. Okay. Was checking my math here. Yeah, wait, hold on. Yeah, we're good, we're good. So we get negative 2. So any questions about that? So let's take a look at another one. Starting cursive A, but So we want to verify if these are solutions. So again, we want to identify our x-coordinate, y-coordinate, x-coordinate, y-coordinate. So let's test this point. Let's see if it's a solution. So we start out with our line. And we replace y with the y number and x with the x number. Again, this is -3 times x. And is this in fact true? Well, this will be 0 plus 7, which is correct. So that means 0, 7 is and I'll abbreviate solution. It is a solution. Now let's try this other point. So again, we start out with our line. Replace the y with y, or the y with the y number. There's the x is 2 plus 7. Are these in fact the same? Well, what we find is this will be -6 plus 7, and that's not true. Because that's 1. So this one didn't work out. So this means 2 - 1 is not a solution. So any questions about that? All right. So let's say we're going to do this. Let's graph x equals -2. Now, when you have something like this, x equals, this is a vertical line. And it crosses through this location on the x-axis of -2. Questions about that?
Does there have to be 2 points for that one?
For this one, no, not for this one. For this one, for the vertical lines and the horizontal lines, you just need to make sure it passes through the right location. Since this is an x equals, it'll pass through a location on the x-axis, and you're all set. You're good.
Okay, so it's like that for x and y. Like if y was to equal -2, then we just put it horizontally on the -2, like down.
Correct. Now, they might make you plant a second point, like on the actual test. Like you'd put a point here and then make sure you have a point that's vertically above, perfectly above it to get that vertical line. So you'll probably still have to use 2 points, but any point that's directly above or directly below a point located here that'll give you the 2 points. Like you could do a point here and then like a point here, and that would give you that vertical line.
Okay, so it doesn't matter where we put it, just as long as it's above or beneath that same point, right?
Correct. Now for the horizontal line, you're absolutely right. Here, I'll do a horizontal line right here. So for y equals 1, we're going to have a perfectly horizontal line passing through that location on the y-axis. And again, you can draw it with a point here at y equals 1, and then another point just directly across to get that horizontal line. So any questions about that? Now, for graphing a line like this, there are a number of ways of doing this. So one approach is we can just try to do it on the graph itself. So first off, we can identify the y-intercept. This is in the form mx plus b. So the y-intercept is going to be 0, comma b. So 0, comma 1 is what we're going to look at here. So that gives us a point there. Now to get a second point, we can do this one of two ways. Now our slope, here I'll put this as 0, comma 1. This is int for intercept. Now the slope's -1/2. So we can put the negative on the top number. And that's what we usually do. So we have a rise of -1 over a run of 2. So what this says, a rise of -1 means to get a second point, we'll start from our y-intercept, drop down 1, because a rise of -1 means a fall. And then we're going to do a run of 2. Now, run is always left to right. And that would give us our second point. And then connecting these points, That's going to give the line. So that's one way of doing this. Now there is another way. It's not mentioned in the book, but I'll go over it. Not quite that much room. Oh, no. A little economical with space. So once again, we're going to start with the y-intercept. We want to identify the y-intercept. And once we've got that figured out, we can come up with a second point like so. So the second point is 0 plus the run, and this is going to come from the slope, and b plus the rise. Now again, our slope m, -1/2. We put the negative on the numerator of the top number. So the rise is -1, and the run is 2. And so that means for a second point, 0 plus run, comma, b plus rise, this will become 0 plus 2, comma, 1, because b is 1, plus -1, or 2, comma, 0. And so that gives us the second point. Connecting these 2 points, that's going to give us our answer. So there's a couple ways you could do this. Any questions about that? All right. So let's say we're going to do this. Let's find the x-intercept and the y-intercept for 8x minus 4y is equal to 16. So to find the x-intercept, we always do this. We start out with y is equal to 0. First thing. So that means 8x minus 4y equals 16. This will become 8x minus 4 times 0 is 16, or 8x minus 0 is 16, 8x equals 16, divide both sides by 8, and we'll get x is equal to 2. And so now the x-intercept, x comma y, is 2 comma 0. So any questions about that? So that's the x-intercept. Let's look for the y-intercept. Now in this case, we start out with x equals 0. So 8x minus 4y is equal to 16. 8 times 0 minus 4y is 16, or 0 minus 4y is 16, or negative 4y is 16. Divide both sides by negative 4. We'll get y is negative 4. So what we get is x comma y is 0, negative 4. So that's going to be our y-intercept. Now, I mentioned there were different ways for graphing lines. This is another way you can graph a line. If you're absolutely not sure what to do, but here's our x-intercept from 4, and here's our y-intercept. Remember, to graph a line, you just need 2 points. So you can generate 2 points by coming up with an x-intercept and a y-intercept. So here's 0, negative 4. Here's 2 comma 0. And then we can graph this line. We don't even have to solve for y. Didn't even solve for y. We can come up with just the x-intercept and the y-intercept, and that's going to give us the line. So the y-intercept is always on the y-axis, and then the x-intercept, 0, 2 comma 0, is always on the x-axis. Questions about that? So now let's do this. So let's try to find a slope. Now, what I recommend is labeling the coordinates. And so we're going to use this slope formula. It's always going to be this. Y2 minus Y1. So the difference of Y's will go on top. The difference of X's will go on the bottom. And you want the same type of difference on the top and on the bottom. So Y2 minus Y1, X2 minus X1. We have 6 minus 2 over negative 5 minus 3. So it'll be 4 over negative 8, or 1 over negative 2. And as sort of a custom, we put the negative out front or put it on the top number. We'll get negative 1/2. Questions about that? So this is something to mention with slopes. When a line is like this, the slope is positive. When a line is like this, the slope is negative. When it's perfectly horizontal, the slope is 0. And when it's perfectly vertical, the slope is undefined.
So do you mean like the coordinates are negative and positive and all that stuff, or?
The actual slope, the coordinates of the points, they could be all kinds of things. But if you took 2 points on this line and you calculated the slope using these 2 points, you get a positive slope. And if you picked any 2 points on this line and calculated the slope, you'll get a negative slope. Doesn't matter which 2 points you pick. If you pick 2 points on this line and calculate the slope, you'll always get a slope of 0. Doesn't matter what 2 points you pick. For this one, if you pick any 2 points on a vertical line, you're going to get an undefined slope. And the way you'll know, you'll get a division by 0. If you try to calculate the slope of a vertical line, you'll get a division by 0, and division by 0 is undefined. So for example, here, I'll do an example of one of these. let's say you have this. And let's say this is x1, y1, and this is x2, y2. Now, the way this line is, this is what you would expect for a negative slope. So let's see. Let's see if we do the computation, it comes out negative. So you have 1 minus 4 over 1 minus 0. It's going to be negative 3 over 1. And sure enough, you get a negative slope. So it's the slope that's negative. Like the coordinates here, except for 0, which is neutral, the coordinates here are all positive. But the slope is going to come out negative. Does that help?
Yes.
Ah, perfect. So let's find some equations. And the thing with like a lot of the graphing, I just recommend practice. Because it's one of those things you want to keep practicing to get the hang of it. It's not something that's easy to figure out the first time, not at all. So let's find the equation of a line with slope -1/2 passing through 4, 1. Now what we're going to use here is what's called the point slope formula. So the slope we're going to call m. And the point we'll call x1, y1. And so this is the point slope formula. This is one of those things you want to try to memorize, just like the slope formula. So we replace y1 with 1, m with -1/2, and x1 with 4. Now we're going to distribute the -1/2. So you get -1/2 x. Now negative times negative is positive, and half of 4 is 2. So you have a positive 2. And then finally, we want to put this in what's called y equals mx plus b form. We want to solve for y. So y is -1/2 x plus 3. And that's going to be our answer. Questions about that?
Yeah, can you do, okay, can you do it again?
Oh, yeah, sure.
I was like, wait.
So we're going to use this particular formula, and this is just one of those formulas you kind of keep under your hat. And the slope is going to be m, and the point is going to be x1 and y1. So what we're going to do, we're going to replace m, x1 and y1 with all the appropriate numbers.
Okay.
So in this case, y1 will be 1. M is going to be the -1/2. And then x1 is going to be the 4.
Okay.
And then you're just going to solve for y. We'll distribute to get rid of these parentheses. And then negative and negative is positive. Then 1/2 times 4 is 2.
Okay, so then right there, with the fractions, because I would put like an imaginary like line and then a 1 under the 4, and then I can cross cancel, right?
Exactly. Well, what you could do, you'd have it like this.
Yeah, and then I could just,
You'd multiply across. I got to go up here. You get 4/2.
okay, and then it goes to 2. Gotcha.
Exactly. Perfect.
Would turning the fraction into a decimal give you the same answers or no?
It will give you the same answer. If you do on the test, if you turn a fraction to a decimal on the test and it marks it wrong, let me know. I can go back and take a look at that.
Okay.
Yeah, if it marks it wrong, let me know.
Okay, thank you.
No problem. Yeah, because that is math. You are mathematically correct. And you add 1, and then that's it. That's going to be the complete answer.
Okay.
So any other questions about that? All right. Now this one, find the equation of a line with slope 3 and y-intercept of -5. Write this a little differently. So what we're going to do here, when we have a slope and a y-intercept, now x-intercept, if we have an x-intercept, we have to use the point slope formula. That's just something we're going to have to do. But when we have a y-intercept, we kind of luck out because we can use y equals mx plus b. where this is the y-intercept 0, comma, b.
It's always 0, comma b, right? For the y-intercept, like when it's like this in this
Correct.
formula, it's always 0 b. Yeah, 0, comma b.
That is correct. Always 0, comma b. Now, an x-intercept will always be a, comma, 0. Your x-intercept will always be a, comma, 0. And there's no formula using the x-intercept. For the x-intercept, you'll have to use the point slope formula. Now for this one, the slope is 3, so that means m is 3. The y-intercept is -5. So that means 0, comma b is 0, -5, or b will be -5. So this means y equals mx plus b will be 3x plus -5, or 3x minus 5. Questions about that? All right. Now again, if you had an x-intercept, you want to be careful with this one. If you have an x-intercept, you have to use the point slope formula like we did in the previous example, number 10. And if you're not sure, you can always use the point slope formula. If you're not sure, can I translate this into mx plus b? You can always just use the point slope formula and you'll get the right answer. That'll always work. All right. So for this one, to find this equation, we need to find a slope. So I'm going to label these x1, y1, x2, y2, and then the slope. We use our slope formula. So here we're going to use both the slope formula and the point slope formula. Get 2 plus 4. This will be minus 9. So you get 6 over minus 9. This reduces 2 over minus 3. And again, we write this as -2, 3 like this. So that's how we compute our slope. There's our y2 is 2, y1 is -4, so we get a double negative that becomes a positive. x2 is -6, x1 is 3, 2 plus 4 is 6, -9, 2 over -3, or -2/3. Questions about that?
And then we don't change anything, right? Once they're, I mean, if it's an improper fraction, we leave it as an improper fraction, right?
If you did get this is a proper fraction.
Oh, I'm sorry. Sorry. Yeah, proper. I'm sorry, an improper. We leave it if it's improper.
Correct. Correct.
And what happens if we, I mean, I could be doing them wrong, but is there ever a time where you come across like a mixed fraction?
You shouldn't. You really shouldn't. If you did come across like a mixed number, I would say convert it to an improper fraction. It just makes life easier.
Okay.
Now we're not done with this one yet. We've got the slope. The slope's -2/3. But we need to find the equation. So to do that, we're going to use that point slope formula. So y1 is -4. The slope that we found was 2/3. So this one you have to do two things. You got to come up with a slope, and then you got to use the point slope formula. Then x1 is 3. Now, if we wanted to, we could have used y2 and x2. We could have done that. But I'm just going to go with x1, y1 because it's there. So this is a double negative. Y plus 4. If we distribute the -2/3, -2/3 x. Negative times negative is a positive. And then 2/3 times 3. Well, again, we'll put that invisible 1 there. We can multiply across. We'll get 6. 2 times 3 is 6. 3 times 1 is 3. And we're going to get 2. So this will be 2. And then subtract 4 from both sides. And that's going to be your answer.
Okay, so for this one, Mr. So since there's two coordinates, like, I mean, two pairs, like the 3 and the 4 and the 6 and the 2, does it matter which, I mean, I'm pretty sure it does matter which one we use, right?
It actually doesn't, as long as you're consistent. So we use -4 for y1, 3 for x1. Or we could have used 2 for y1 and -6 for x1.
Oh, okay.
That,
So probably would have came out with the same is what
you would absolutely get the same answer.
Okay. So it doesn't matter. Okay.
Correct. It's just like if you change this 2 and 2 and 1 and 1, like x2, y2,
Right.
x1, y1, it would be perfectly fine.
Okay. Yeah, because I think in one of the videos for XYZ, I looked, and I think that's how they set it up.
Yeah, no, that's perfectly fine. Yeah, you can do that.
Okay.
Let's see. Now let's take a look at this one. So this one, I'm just going to kind of outline it for the sake of time. Let's say we have well, I'll go through this one. So let's say you need to find the equation of the line that we're looking at here. Well, first off, we see there's a y-intercept. So the y-intercept is 0, 4. And that's going to be 0, comma b. Or that means b is equal to 4. So that's the y-intercept of 4. The next thing to do is to find the slope. We just need the slope. And then we could use the y equals mx plus b form to get the equation for this line. So I'm going to let this be the x1, y1. This is the x2, y2. So what they've done, they've only given us this line that passes through these 2 points. So what we needed to do is identify what the point is. This is 0, comma 4. This is negative 3, comma 0. We want to identify those points. And then we can recognize this is a y-intercept because it's crossing the y-axis. So that means our b that we're going to use in y equals mx plus b, that's going to be 4. Now we're going to use these 2 points to come up with the m, or the slope. And negative divided by negative is positive, which is what we would expect with this line because it's sloping up. So for the answer, we're going to use the form y equals mx plus b. And we know m is 4/3. Again, improper fraction right there. And b is just 4. And that's going to be our answer. Questions about that?
How was this question presented? Like how would it have been presented?
It would have been this. You would have had a line, and that's it.
Oh, okay. Okay.
It just would have been this. And so what you'd have to do is identify this point, recognize that's a y-intercept, and that's going to give you b. Find the slope between these 2 points to get m, and then you can put together your y equals mx plus b.
Okay.
Let's see. So let's say we want to find a line that's parallel to y equals -1/2 x minus 7. So for parallel lines, we just need any line that has the same slope. So m is -1/2. So that means any line with the same slope will work. So you could go -1/2 x, -1/2 x plus 2, and so on. But these will all be parallel to this line. Questions about that?
Okay, so I'm trying to figure out because I'm just confused.
You could pick any line, you just enter it into XYZ, and as long as that line has a slope of, in this case, -1/2, it would be correct.
Okay.
Now let's say we have this question though. Let's find a perpendicular line. Now for a perpendicular line, so we have our slope, this is for our line. The perpendicular line, it's -1 over this slope. Now this is just the slope, it's not the line. We get -1 over -1/2. And to do this computation, we have negative over negative is going to be positive. So this is 1 over 1/2. And whenever you have something over something else, that just means division. This is a fancy way of saying division. So we've got fraction division. So 1 with that invisible 1 divided by 1/2. And then we do our KFC. We keep the first one, we flip the second one, we change division to multiply. And now we multiply across. We'll get 2 over 1, which is 2. So that's the perpendicular slope. But the formula for the perpendicular slope, it's whatever the slope is, you're going to take -1 divided by whatever the slope of the original line is. Now again, that's just the slope. The actual line, it's...
So, okay, well, just how you said, so the -1 over m, that's the formula for the perpendicular line?
Correct. It's the formula for the perpendicular slope.
Okay.
And so the actual answer is any line you come up with that has this slope. You just have to make up a line, and then that would be your answer. So I'm going to do a tricky problem here. Let's take a look at this. This one I think is kind of tricky. So let's find a line. Find a line perpendicular to 4x minus 2y equals 3, passing through 0, -6. And this one, we're going to use, we're going to do 3 things for this one. Well, first we got to find the slope of this line. So what I'm going to recommend is find slope m. And there's different ways you can do this. I'm going to put it in y equals mx plus b form. I'm going to solve for y. And then next, divide by -2. Now, once again, we're going to break things up. And I'm going to do that typical thing. We put the minus in front. Now, this is negative and negative is positive. And if we take 4 divided by 2, or if you have 4x and you divide it by 2, you'll get 2x. Or half of 4x is 2x. So any questions about that? So finally, we can identify m. It's the number attached to x. We get m is equal to 2. So any questions about that? So that's the first step in this question. So we found m. So the slope of this line is m equals 2. So that's the slope of this line. We found that in step 1. Now for step 2, let's find the perpendicular slope. That's minus 1 over m. Or in this case, minus 1 over 2, or minus 1/2. And so that gives us our perpendicular slope. So now we get to step 3. Well, any questions about that? I'm sorry, any questions? So for step 3, we have a perpendicular slope. And we represent perpendicular. We can do this sort of a shorthand like this. And we need this perpendicular line (0, -6). So to find a line with this slope passing through this point, we're going to use our point slope formula. Except this time we're going to use the perpendicular slope. So for x1 and y1. So any questions about this? This is kind of a long problem. And the double negative. We distribute the -1/2. Well, negative and negative is a positive, but 1/2 times 0 is 0. So subtract 6 from both sides. And that's going to be our answer. Questions about that? So the last question I'm going to do now, I'm going to use the new method. I'm going to use the type 2 method. So I'm going to solve for y. Which you would do in the first method also. And then we'll divide by -9. Since we're dividing by a negative, it makes that swing around. So we'll get y greater than or equal to 18 over -9 minus 6x over -9, where y is greater than or equal -2. Negative and negative is positive. And then we'll just finish over here. We get y greater than or equal to -2. This reduces the 2/3. So you have 2x over 3. And then what we typically do is we rewrite this as -2 plus 2 over 3x. I'm just going to switch the order here so it's more in that y is mx plus b form. So when we solve for y, we're going to get this. So any questions about that?
Do we always switch the formula around to like make it the m plus bx? Or
I recommend it. You don't have to. You could just use intercepts to graph the line. Any method that's going to let you graph this line is going to help. So to actually graph this, now because it has an equal to, it's going to be a solid line. So I'll use both methods for doing this, the test point method and the new method. So we have a y-intercept of 2, -2 rather. And then for this slope, we have a rise of 2 and a run of 3. So we go up 2, we run 3. And that gives us our second point. And so we graph the line as if it was an equal sign instead of an inequality. So now I got to figure out the shading. Now, if this was this kind of a thing, this would be a dashed line. But since it's this, it's going to be solid. But now we got to figure out the shading. Now, the new method says since we solve for y and y is greater, that means we shade above the line and then we're done. But let's say we didn't solve for y. Let's say we graph this using intercepts. Well, then what we want to do is choose a test point that's not on the line. I say choose an easy test point. Choose something like this, like 0, 0. And then what we're going to do, we're going to test this point. So we're going to replace x and y with 0 and 0. So is 0 greater than or equal to 2/3 times 0 minus 2? Or is 0 greater than or equal to 0 minus 2? Well, sure enough, 0 is greater or equal to -2. That is correct. So that means we shade above the line. And again, you could use the second method where it says since y is greater than, that also says you shade above the line. So either method will work. Questions about that? All right. Well, that's it for today. That's your review. I mean, any questions about this, let me know. We'll do the exam on Monday. Other than that, have a wonderful weekend and just let me know if you have any questions.